Welcome to Mr. Benjamin's Math World. Today we are going to be working with division of complex numbers. First we need to know what a complex number is. A complex number is formed by two parts. A real part, which is a number, and an imaginary part, which is this term 3i. The imaginary part will always have this variable I. And it's always good to know that I is the same as square root of -1. And therefore, if we replace the radical will cancel out and it will become a power. So this would be I to the second is equals to -1. So what I did actually was I replaced the radical for the power 2. And this is the information we always need to keep in mind, that I to the second is the same as -1. We should keep this in mind because we are going to be using it later. Now, let's divide these two complex numbers. And by the way, they are also binomials. As we know, a binomial has two terms. One term, two terms. One term and two terms. So let's divide this. In order to divide complex numbers, we need to know and we need to get familiar with a term. And this term is the conjugate. For example, we got, let's take this as an example, 4 minus 2i. What is the conjugate of 4 minus 2i? Conjugate means just to change the sign between the terms to its opposite. Only the sign between the two terms. So the conjugate of 4 minus 2i will be the same 4. Instead of a negative sign, the opposite of a negative is a positive one. So this is 4 plus 2i. Therefore, 4 plus 2i is the conjugate of 4 minus 2i. So let's divide this. How do we divide it? Because we multiply both the numerator and the denominator times the conjugate of the denominator. Not the conjugate of the numerator. It's the conjugate of the denominator always. It means that I'll be multiplying in the numerator 4 plus the conjugate 2i, and also in the denominator I'll be multiplying 4 plus 2i. So what I'm doing here is I'm multiplying 2 plus 3i times 4 plus 2i, and I'm also multiplying 4 minus 2i times 4 plus 2i. Let's multiply this. In order to multiply binomials, as we have seen in previous classes, we may use the FOIL method. Let me remind you, FOIL, this is first, this is outer terms, this is inner, and this is last. So we are going to be multiplying the first terms, the outer terms, the inner terms, and the last terms. Let's multiply. This is 2 times 4 is 8. 2 times positive 2i is positive 4i. Inner terms. 3i times 4, inner terms. 3 times 4 is 12i, and the signs positive times positive is positive. This will be 12i. And then multiplying 3i times 2i, positive times positive is positive, and multiplying 3 times 2 is 6, and I times I is I squared. Reminding you why squared, because we know that when multiplying variables, the same variables, they have a 1 up there, so what we do is we add the exponents. So it's 6i to the second power. We have the result of the multiplication of the numerator. Let's do the same we did in the denominator. Let's multiply by using the FOIL method. 4 times 4 is 16. 4 times 2i is positive 8i. Negative 2i times 4 is negative 8i. And negative 2i times positive 2i is negative 2i squared. Again, because I times I is I to the second. So let's see if we can find some like terms here. Like terms, these two. These two are like terms because they have the same letter, the same variable, and the same power, 1 and 1. This one is not a like term. It does not have a like term because there's no other I to the second in the numerator. And this is just the independent term, is just a number. There's no number by itself in the numerator. So I'm going to solve the like terms up there. I'll bring down the 8. 4i plus 12i is positive 16i, not I to the second, because what I'm doing here is I'm adding here. I'm not multiplying. This is not multiplication. This is addition or subtraction, depending on the signs. Right now I'm adding because, as we know, the rule says when the numbers have the same signs, we just add the numbers and we keep the same sign. So we are dealing with addition and subtraction also. And then bring down the plus 6i to the second, but there's something I showed before. I to the second. And we know that I to the second is the same as negative 1. So I'll use that advantage. This would be plus 6i to the second instead of I to the second negative 1. But the negative 1 is multiplying the I. Why is it multiplying? Because 6i to the second means 6 times I to the second. The same as 6 times negative 1. I'm going to work out the denominator, doing the same thing I did up. I'll bring down the 16. And then I'm going to solve the like terms here. It says plus 8i minus 8i. They'll cancel out because they have different signs. So I subtract the numbers. When you subtract 8 and 8, you get 0. And 0i is 0 times I, which is 0. So it means that these two will cross out. And then I'll bring down the negative 2i to the second again. So instead of I to the second, I'll replace it by times the negative 1. I'm going to solve. We have 8 plus 16i positive 6 times negative 1. Positive times negative is negative. 6 times 12 is 6. Over 16. Negative 2 times negative 1 is positive 2. Because 2 times 1 is 2. And negative times negative is positive. And the result will be the like terms again. They are 8 and minus 6. 8 minus 6 is 2. Positive. Because the rule says when the signs, positive and negative, are different, the rule for addition and subtraction, when the signs are different, we subtract the numbers, which is 2, and we copy the sign of the greatest. Which one is greater, 8 or 6? 8 is greater than 6. What's the symbol? What's the sign for 8? Positive. So it's positive 2. And bring down the plus 16i over 18. And this is the result of this. But if it's always an advantage to present this as complex numbers are presented. It means that a real part and an imaginary part. It means that I can also show this, the 2 plus 16i over 18. The 18 is dividing both of the terms in the numerator. 18 is dividing not only the 2, but also the 16. So I can also show this as, I'll put it down here, 2 over 18 plus 16 over 18i. And I may also simplify this fraction by getting half of each. So this would be half of 2 is 1, half of 18 is 9. So this would be 1 over 9 plus, I can also simplify this. Half of 16 is 8, and half of 18 is 9i. And now I got the complex number with the real part and also the imaginary part. Remember, we call it imaginary because it has the I, which is it defines a complex number. And this is the answer for the multiplication of complex numbers. If this video was useful, please feel free to subscribe and activate the bell in order to receive further notifications. See you next class.